Okay, so let's try find and classify all the critical points for f of x and y is x squared over 2 plus 3y cubed plus 9y squared minus 3xy plus 9y minus 9x. Whoa.
Whoa.
Right? Whoa.
You can cut
Okay.
that in half whenever you do your f of
So what do I need to do?
First, let's find the gradient of f.
Find partials, right? Why am I finding partials?
This is
Isn't there
important.
like a second partial?
Yeah, because you're trying to find critical points, right? What's a critical point? Where the derivative is 0, right? So you better find some derivatives. Okay, so fx of x and y is x, that's zeros, minus 3y minus 9.
No.
Cool?
Y.
And then fy of x and y is 9, okay, that's zeros, 9y squared.
Minus 3x.
Plus 18y.
I think I got a plus 18y
Yeah. Then it's
minus 3x
plus 9.
Plus 9.
plus 9.
And then you might want to have these down for later.
Oh yeah, and then I'll need the second derivatives for later, right?
Yep.
Okay, so we may as well get those while we're differentiating.
Yeah, fix.
So fxx of x and y is
1, 2,
Yeah, 1.
1. Fyy of x and y is
18y plus 18.
18y plus 18. And fxy,
For this one case, doesn't matter, but it's negative 3.
we're in the nears. It doesn't matter. It's negative 3.
okay. Which derivative did you go to take this?
Both.
You should go to f of x first.
The y partial with respect to x.
So you get negative.
Yeah, so this should be differentiate the y partial with respect to x. Right, because they go like function composition.
Yep.
So that would be this one, and then differentiate with respect to x. But that's harder for some reason. So I'm going to do this one.
They're both negative 3.
But they're both negative 3s.
Yeah, they came out to be the same.
And they should be the same, right?
Yep. Because we're engineers, so we don't have to worry about chloros.
Because Claros says they should be the same in cases where the function's nice. And in this case, the function is mega nice. Cool?
So you
All right.
could find the min, max, and saddles in this equation, but you don't have to.
What? No, you have to.
No, it says find.
Find and
Oh,
classify
classify.
the critical
I
point.
thought I just said find. Okay.
Okay, so now what?
I did it anyways, but I
Equal
thought.
to 0.
Set them equal to 0.
Yeah.
So take your first partials, your x partial and your y partial, set them equal to 0. Then what?
You might want to find
You find more
x
equal
so
to
that you can plug it into y.
Yeah.
Okay, so take this first equation, get x is 3y plus 9.
You know?
Plug that in.
Take that information and cram it into
The other function.
this, shoved in there.
And I got y squared plus 3y minus
Wait.
Hang on. So I got 9y squared plus 18y minus 9y minus 27 plus 9.
Yeah. So you should get y squared plus y
So I got-
minus 2.
9y squared plus 9y minus 18 is 0,
Which is y squared plus y.
which is
minus
y
2.
squared plus y minus
2.
2 equals 0. Which tells you what?
Move the 2 over.
Yeah, you can do that.
Then you can.
Exactly.
You still
You
get.
could
You just move the 2 over. It's easier in the end.
No, it's not.
Factor.
No,
That's
factor.
not a factor.
Yeah, factor.
You want two numbers that multiply to negative 2 and add to 1, right?
X plus y plus 2, y minus 1.
So they're 2 and 1.
I
2 and negative 1.
And then,
You get y equals negative 2 and y equals
how? What did you apply?
that, like, because they're multiples, one of them has to be
What is that
zero.
freaking thing called? I don't
Yeah,
know.
what is that freaking thing called? Come on, y'all.
Zero product.
Zero.
The zero product rule.
Yeah, zero
I don't know
product.
the name.
Zipper. Zipper. So you get y is -2 or y is 1. Okay, then what do you do with that? Yeah, take that and trot it where?
Into
One of those two
your,
original.
one of your, the easier equation.
Take this information and trot it back up there.
Yes.
Could you do it in the second one or no?
Yeah, sure, you could. It'll
Or
suck.
maybe not fun. Right or
Okay, so my points are going to be something comma -2. What is the x that goes with -2?
Three.
3. Okay, then the other one's going to be something comma 1.
It's 12.
So I'm gonna start.
12. Great. Okay, then what?
D test.
Then I need the second derivative test, right? So I need to trot out d. So I need d of x and y. Oh, what the hell? I need d of 3 and -2, right? Okay, so how's d work?
Was it XX plus YY
No.
minus?
No, XX times YY.
It's fxx times fyy. So you got
The same thing.
18 times your y plus 18, right? And then
Minus.
minus
Minus 2.
3 squared.
fxx,
9 words.
or fxy rather,
Squared.
squared. Okay, so into y goes what? -2. Okay, so all told here, I got -36,
That would make those different.
-18 minus something is negative. Right? I don't care what, it's negative. What does that mean? Saddle. Is a saddle. Well, bam. Say again? Yeah. So the cross that you're doing to get you D is fxx, fxy, fyx, fyy, and take the determinant.
Oh. So it's not a real cross, but it's crossish.
Yeah, it's a determinant. It's a
determinant.
Jacobian, right?
Yeah. It's a two-dimensional determinant, so when you get to linear algebra, that's easier.
I forget, is fxy and fyx the same?
Yeah, they're the same for nice functions, right? That's Clairaut's theorem. Clairaut's theorem has to have, you have to have a really pathological function for Clairaut's not to apply. So if you're doing math about the real world that's not really heavy-duty quantum physics, you could probably just assume fxy and fyx are the same. Okay, so I got negative saddle, good. How about the other one? I got D of 12 and 1, right? So that should be 18 times 12 plus 18 minus 9 is definitely positive because 18 times 12 is big.
Yeah.
Mine is 9. Wouldn't it be 1 squared in there? Why are you using -3 if you do the 12 1 squared? Oh.
Because -3 doesn't, right, that fyx doesn't depend on x or y, right? It's always -3. So once I know this is positive, what does that tell you?
It's a min or max, and then you realize that the f of xx is positive, so we're only finding minimums. We're not going to find any maximums.
You guys see that? This guy's positive, right? that means at least in the XX direction, this thing is concave up. You guys see that? Like really in the X
Wait,
direction, this thing's
Why are you
concave up.
multiplying by 12? Shouldn't you be multiplying by 1 since it's a y?
Oh, good point.
Yeah,
But it doesn't matter.
It doesn't
but still.
matter, but yeah,
Thank you,
that is
Greg.
worth noting.
That was my bad.
You have to check the XX and the YY to see if they're both positive or just one of them.
You just check one of them.
You can just check one of them. They will both be the same. That's what
A minimum.
the D test tells you.
Going back.
Okay, so in the end here, I got positive and I got concave up, which is a minimum. I wrote is a saddle and is a minimum. What else should I probably add to that 12, 1?
F of 12.
Is it a global or a local minimum?
That is
Local?
It should be global, it's kind of like a traveler, right?
Give me a good justification.
There's a cubic in the y, so it's going to...
Good. Y cubed is actually the biggest power here, right? So that's going to tend to dominate, yeah? So as you go towards positive y's, you're going to get a really big positive number out of this thing. As you go towards negative y's, you're going to get a
Really small negative.
really big negative
Yeah,
number.
really big number.
And hence, you're going to get past this minimum.
So local.
So this is a local minimum. You guys cool with that?
wants to specify whether it's local or global on the test.
Yeah, it would be great if you could demonstrate that you know whether things are local or global. If you write local and it's a global, that's not such a big deal. If you write global and it's a local, that's a big problem. You guys see that? Right? Because a global minimum is a local minimum. Right?
Local minimum.
You're still right. You just haven't realized something kind of cool. Right? Like there's a bonus that you missed, which is not only is it a minimum here, it's like a minimum everywhere, which is awesome.
So that would be like 9 points out of 10.
Yeah, totally. I maybe wouldn't even take a point off if you didn't notice that something was a global minimum. But if you tell me that something's a global minimum and it's only a local minimum, that means you have some problems about your understanding of minimums. You guys see that? Okay.
Quick question.
On this?
Why, yeah, just why do we not mix and match?
Yeah.
Mix
Why
and
do we
match.
not have 3, 1, and 12, negative 2 as options?
Oh, why do I not have 3, 1, and 12, negative 2? Those are reasonable questions.
Your x depends on your y when you find it, so you can't do that.
Because it also had, on previous one, x also depended on y, but they were squared, so I don't know if that has a factor into it.
So the thing here, right, is that both of these equations here, right, these are my partial derivatives set equal to 0.
Oh wait, no they weren't.
Both of these have to simultaneously be true, right? Like it has, both equations have to be 0. If you plug 3, 1 in here, right, you'll get 3 minus 9,
Not 0.
which is not 0,
Okay.
right? Really, it's that this 1y of negative 2 gave me the x of 3. That x of 3 doesn't go with different y's. It goes with negative 2. You guys see that? Cool. Questions, Steele?
That makes more sense. Thank you.
What's up?
So we did try to find what those points were, would you dock us on the test?
Yes. Because those are not critical points. You guys see that? And actually the D thing, like going to a second derivative test doesn't make any sense there because the first derivative wasn't 0. Right? You'll get a number out of it. It'll be nonsense.